Welcome to Pythagoras Theorem. Today we shall be looking at the Pythagoras Theorem and we shall be proving the law as well. The Pythagoras Theorem is basically applicable to right angle triangle. It is only in right angle triangle that this particular law is mainly applicable. Now let us go ahead to know what the law is talking about and then the proof as well. Now let's go. This is the diagram of a right angle triangle. A type of triangle that forms 90 degrees in one of the three angles is the right angle triangle. Now this is angle A here, this is angle B here, and this is angle C. And if you look at this right angle triangle here, this line AC now is the longest. The longest side in a right angle triangle is called the hypotenuse. Now this side is the base, BC is the base, and the AB is the perpendicular heights. Now this is a right angle triangle. According to this man, Pythagoras, he says that the longest side from this line A to C, which is the hypotenuse, that when you bring the hypotenuse now and square it, it will be equal to, when you bring the base, let us use B as the base, as the B squared. Now this is the perpendicular, and this is the perpendicular height now, plus the H, the perpendicular height squared. I get to the point now. That it is the square of here plus the square of here will give us this particular place. That is what this law is talking about. And it has a proof. Alright, let us know if this man is this man is actually correct in what he said. Let us go to the proof. Now, the first thing to do, construct the perpendicular bisector of AC to meet at this point D. Now, and if you look at this particular line, it is drawn from here, and it makes cuts this particular line at D, thereby making angle 90 here. When this line is drawn, it has automatically divided this particular right angle triangle into two. Now we have three triangles here. We have the biggest triangle ABC, and we have triangle ABD, and we have triangle BCD, this one and this one. Are you getting the point now? Now, if you look at it now, you find out that all of them are right angle triangle, but they're not the same in size. Are you getting the point? They are the same, but not same in size. So they are similar by virtue of the AA. AA means angle similar property. They are the same, they are similar by the virtue of the AA similar property, angle similar property of a triangle. Why? Because this is right angle triangle, it has angle 90. This is also a right angle triangle, it has angle 90. This is also right angle triangle, it has also angle 90. Are you getting the point now? And if you look at since they are similar, it means that from A to B is the hypotenuse of this particular one. You look at this particular one there, B to C is the hypotenuse of this particular one. While A to C, the hypotenuse of the what? The biggest one. Alright, let us take it now, since they are similar, let's take it AD, one of the sides, AD over the hypotenuse of the smaller one, AB, equal to, make it equal to the bigger one, since they are similar. Are you getting the point now? AB over the AC of the bigger triangle. Alright, I cross multiply. Let us cross multiply. AB times AB will give us AB squared equal to AD times AC will give us AD times AC. Call this one now equation 1. Alright, let us now come back to the small triangle. The one here, that is triangle BDC or BCD as the case may be. No matter how you take it, no problem, that's same. Alright, here is the hypotenuse and here is one of the sides. Alright, so let's go. DC over BC. DC over BC. Also, make it, equate it to the biggest triangle as well. Since they are similar, over BC equal to BC over AC. AC. So, cross multiply again. BC times BC will give us a BC squared equals DC times AC will give us a DC times AC. This is equation 2. Now, bring equation 1 and 2 together. Bring them together. That is, add them up. So, this is our equation 1. This is AB squared equals AD times AC. These are equation 1. This then add it to our equation 2, BC squared. BC squared equals our DC times our AC. These are equation 2. So when you add it up now, we are going to have that AB plus BC will give us AD times AC plus DC times AC. So this is what it's going to give us. I get it now. Now factorize the right hand side. Factorize the right hand side. Factorize R, the RHS. What do I mean by factorization? If you are given 6 and 9, and you are asked to find a common factor between 6 and 9, that's factorize 6 and 9. It means, what do 6 and 9 have in common? What number do they have in common? What they have in common here now is 3. That means 3 can divide 6 without remainder. 3 can divide 9 without remainder. So here now, what is common here? AC is here, AC is here. So that means AC is common here. So when you bring out that AC, which is common, we're going to have that AB squared plus BC squared. Then AC is common. Bring that AC, which is common. Use to in the bracket of AD times AC over AC plus DC times AC over AC. I get the point now. AC will cancel AC, AC will cancel AC. So we are now left with AB squared plus BC squared equals AC in the bracket of what is remaining here now? AD is remaining, DC is remaining. So we have AD plus DC. Do you understand? Alright. Now, if you look at here now, you find that AC, line AC here, line AC is equal to AD. That is from here to here, and from here to here gives us this longest side. Is equal to AD plus DC. Can you now see? That means anywhere you see AD plus DC, you replace it with AC. So if you do it, what we're going to have finally is AB squared plus BC squared equal to AC, and AD. Don't forget that AD plus DC is the same thing. It's the same as particular line times AC, and AC times AC gives you AC squared. So finally we have that AB squared plus BC squared equals AC squared. So this is the proof of this particular law, that here the square of here or the square of here gives us the square of this particular system. So look at it. Look at it. Do you like it? Alright. So make sure you share this video. Share it to your GS2 students, share it to all the students, share it to your friends, your parents, and so on and so forth. If you like it, make sure to subscribe to our YouTube channel at Pythagoras Theorem. See you in our next class. Thank you so much.